All right, in this video, I'm going to show you the same function, but in two different forms, one in standard form, and the same function, but written in factored form. And I want to show you that you can graph your function no matter what form you have, and that your picture should be identical. So real quick, I just want to highlight a couple things. Here's our function at the top, and I want to just make note with you that this is our standard form, and this is our factored form. Now, if I just real quickly want to point out to you that two numbers that multiply to make -8 and those same two numbers that multiply to make -2 will be a -4 and a +2, and notice how those numbers show up in your factors here. And I just want you to know that they should be the same function, because if I were to multiply this out, I'd have x squared plus 2x minus 4x minus 8. These two middle terms do combine to make -2x, so I know I have the same function, which means your graphs should be identical. But again, I want to walk you through the process of how do you find the parts of the graph that we were talking about in the previous video. So specifically, standard form is used to find your axis of symmetry, your vertex, min and max, and your y-intercept, versus factored form really is only, well, mostly useful for quickly finding your x-intercepts. You can still find the other things, it just takes a different approach. And so here, side by side, I'll start with my standard form, and then we'll do our factored form. So standard form is called ax squared. So a, the number in front of my x squared term, is 1, and then plus or minus your bx, so I have a -2 for my b term. And then for C, I have -8. And so just identifying the parts, A, B, C, are how we're going to identify our axis of symmetry, because we need the formula filled out for that, which is opposite B over 2A. So this is going to get us our axis of symmetry. So opposite of -2 is +2. And if I divide by double my A term, which will be 2 times 1, this will simplify to 2 divided by 2, which is going to get me an axis of symmetry of 1. Now that's a function, x equals 1, that's a vertical line. So again, just as a reminder, that means we have a vertical line with undefined slope, and the x is going to be the function letter that you're going to use, x equal to a number. And so I'm going to draw that, even though it's not really part of our parabola per se. Our parabola will be perfectly symmetric about this axis of symmetry. So this will be the middle of my picture, and it will reflect equally on either side of that. So now what I'm going to do is find the vertex, and the vertex has to go through that 1. So the middle of my graph has to hit the middle line. So now how to find your y value is you plug in 1 into your function. So to get my y value, I'm going to substitute in 1 for my x, and all the x's that you see, actually. So I have 1 times 1, 2 times 1, and then my 8. 1 minus 2 minus 8, or 1 minus 10, is going to get me -9 for the y value. So this is the vertex for the picture. It's going to be here at 1 and down at 9. So I'm going to put a dot right here, my point for 1, -9. That's my vertex. Now, to find my x-intercepts and to find my min or my max, well, actually, my minimum value is the y value of your vertex. And I already know that the lowest point of my graph is going to be this -9. And because this is a positive x squared, our graph should open upwards from there. And how you can find the rest of your picture, if you don't know the pattern for a parabola, I would recommend that you make a table of values. So I'm going to start with my table. And I'm going to use pencil for this just in case I make a mistake, so I can erase. And my marker's awfully thick. So I like to put what is called my vertex in the middle. And I like to do, if I can, I like to find at least 3 or 4 points on either side of my vertex. So if my vertex is at 1, I want to go forward 4 points and backward 4 points. So meaning 2, 3, 4, and maybe 5. So I'm going to put right in the middle my vertex, which is 1, -9. I already know that. But I'm going to go on the right side 4 if I can. I'm going to try to see if I can graph. So 2, 3, 4, 5. So that's 1 to the right, 2 to the right, 3 to the right, 4 to the right from, again, that's my vertex. And now we'll go to the left 4. So left, so 0, -1, -2, -3. So I want my vertex in the middle, and then I'm going to see, hopefully, a pattern. It should be symmetric around the vertex, so if I find 2, I should get the same answer for 0. And if I find what my function is evaluated at 3, meaning if I plug 3 into the x, I should get the same output as I would -1, because it should be symmetric as you go to the right and to the left. So here, what I'm going to do is actually use my calculator to make this process a little quicker. And I'm going to write down our function up here, y equals x squared minus 2 times x and minus 8. And what I'm going to do is plug in my number where you see that x, and I'm going to plug this into my calculator, but I'm going to put a number in that parentheses like 2 or like 3 or like 4 or like 5. So in for the x for the square here and the x here. And I'm going to type it in exactly like this. So parenthesis 2 parenthesis squared minus 2 parenthesis, again, I'm inputting the number 2 for x, so notice how that's in parentheses, and then minus 8. And I get out for this a -8. And I should get, so to the right of my vertex and to the left, if I go out 1, if it's symmetric and it goes up symmetrically, I should get the same thing as if I put in the number 0. So I'm going to go back and put in a 0 in both of those parentheses, and look, I do get out -8. So my parabola is going to hit here at 2, -8, and at 0, -8. So I'm going to put those 2 points. So notice how these are symmetric across that vertical line. Okay, now I'm going to go back and I'm going to go 2 out for my vertex. So if my vertex is at 1, if I go 2 out, that would be 3. So I'm going to type in a 3 here and a 3 here. Notice you have to use parentheses when you're inputting a value. This is why we call it, I don't know if you've made this connection yet, f of x. Notice how there's parentheses around that x, and notice how when I'm inputting that x value, I'm using parentheses. That's really important. Okay, so here when I evaluate at 3, I get -5. I should get the same thing when I evaluate at -1 because it's supposed to be perfectly symmetric. Now watch, I'm going to have to insert a negative, so I'm going to hit, watch this, I'm going to hit insert second, and delete is my insert negative. And now I'm going to go back and change my 3 to be a 1. And over here, I need to insert a negative. So second and my delete sign will insert that negative. And I'm changing my 3 to be a 1. And I hit enter and I get also -5. So now I'm going to plot that point over here. 3, -5, 1, 2, 3, 4, 5. And it is, we just found symmetric over here. So if I go to -1, I also get 5. So notice on either side, we're starting to get closer and closer here to building more points on our picture. So now I'm going to go 3 out. Since I have the negative already in there, I'm going to start with -2. So I can just go back over my -1 and put a 2 there. 2. So I plugged in -2 and I got 0. And I should have the same thing when I input 4. So now I'm going to show you again. I'm going to delete that negative sign. So I'm going to hit the delete on the negative and change that 2 to be a 4. Again, delete that negative and change that to be a 4. And I'm going to hit enter. Oh, I got 0 again. See, it's perfectly symmetric about that line. So at 4, 0. Oh, look, now I know my intercepts. My x-intercepts specifically. So this will continue to go up this way. And maybe I want to just kind of highlight those points a little bit more. And then now let's plug in the number 5. So I'm going to go out 5. You could start with -3 if you want, but I don't want to insert my negative and then have to take it out. So I'm going to put 5 where I entered in my 4, and I get the number 7. And then now I'm going to go back. Now I have to insert a negative. So again, I'll show you how to do that. So where I see my 5, I'm going to hit second and the delete key to insert a negative. And now I'm going to go back. I just kind of get out of the insert then by hitting right or left. And then I'm going to put in for -3 here. So if you want to put the 3 first and now insert. So make sure you're on the 3. You hit second insert and the negative, and that makes it negative. And now I will hit enter, and I should get the same thing, 7. So I'm going to plot that point on my grid here. 5, 7, and -3, 7. So based on symmetry, it's going to get wider and wider by the same amount on either side of your vertex. So notice how those outputs were the same. Now I also want to talk to you about the pattern of change if no one has talked to you about that yet. Let me first label my intercepts because I found them. One of them is at -2 and the other was at 4. The pattern for a quadratic, when your A is 1, notice when we went out 1 from our vertex, we went up 1. And if I go out 2, I went up 1, 2, 3, 4. So out 1, how far did we go up? 1. Out 2, we went up 4. What if I go out 3? We go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Out 3, up 9. What if we go out 4? We went up 9 to get here, 10, 11, 12, 13, 14, 15, 16. Do you see a pattern here? Now, again, we're dealing with squares. Do you see if you go out 1, you went out 1 squared? Out 2, you went up 2 squared. Out 3 from the vertex, you went up 3 squared. And out 4, you went up 4 squared, or 16. If I were to go out 5 from my vertex to here, I would go up 25. Now, clearly that's going to be off my graph, but that's your pattern of your squares. And so hopefully we're making some connections here with quadratics. Again, we're dealing with x squared, so those squares should show up somewhere, and they show up in your graph. Okay, now to compare left and right, side by side, your factored form. We're going to get the same picture, and I want to show you and make that clear. So our intercepts, by putting our factors equal to 0, I'm going to use my pencil just to kind of save me some room. If x minus 4 is equal to 0 and I add 4 to both sides, I get x equals 4. And again, solving, x plus 2, set that factor equal to 0 and solve, you get x equals -2. So those 2 points, 4 and -2, notice how those match what we had said before. So my picture here, out at 4 and at -2, those are my 2 x-intercepts. So this is our steps. So I'm going to put these in order. So what you want to do first when you got factored form is plot your points. Plot, I should say, your x-intercept points. Next, what you want to do is count the units they are apart. Now, if these are supposed to be perfectly symmetric, then I can find the middle, and that's what I'm going to start doing. So if these are 1, 2, 3, 4, 5, 6 units apart, then I can find the middle, which is 3 units. So from here, go over 3, and from here, go over 1, 2, 3. I know the middle is x equal to 1. This is my axis of symmetry. Okay, now, if I know 1 is in the middle, then that means for my vertex, I know I have 1 comma something. So how do you find the y value of your vertex? You plug it into your function. Well, I'll just plug it into this one. So since we had factored form here, I'll show you plugging in the number 1. So y equals, now in where I see my x, I'll plug in a 1. And again, where I see an x, I'll plug in the value 1. We should get the same vertex, because this is technically the same function, right? We even double check that. Well, 1 minus 4 is -3. 1 plus 2 is 3. And -3 times 3 is, oh, hey, the same thing, -9. So I can plot 1, -9, and I know that's my vertex. Okay, so now hopefully, okay, how do you find the vertex in factored form? I actually did all that here, so oops. I should have put all those steps down below. That's okay. Algebraically, I guess I didn't make this very algebraic. I just counted towards the middle. But algebraically, when you find the middle, it's called an average. So average of our x-intercepts. So our average is the sum divided by the total. So we had -2 plus 4. Those were our two intercepts. I'm adding them together, and then I'm going to divide by the number of things that I had. So two x-intercepts, and this would be 2 divided by 2, which is 1, and that was our axis of symmetry. The middle was 1. And then you plug 1 into the function for the y value of your vertex. So we got 1, -9. We already did that up here. Now, how do you find the rest of the points? Well, if you know your vertex, you can do exactly what we did here. Build a table of values, start plugging in numbers into your function. Or, if you know the pattern, write it down. So take your pattern of values. We're going to go out 1, 2, 3, 4 from our vertex, and it will be your A times the squares, 1, 4, 9, 16, and so on. So if your A is not 1, you just do 1 times your A. If it was like, I don't know, 2x squared, so you do 1 times 2, so you'd go up 2 first. And instead of going out 2, up 4, I should have wrote the word up. Instead of going up just 4, let's say if you had, for example, if you had 2x squared, you'd go up double 4. So your A changes your pattern of values if it's not 1. But since I have 1x squared, because x times x is 1x squared, from my vertex, I'm going to go out 1, up 1 squared, which is 1. Out 2, up 2 squared, which is 4. 1, 2, 3, 4. Out 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That point was already plotted because we found our x-intercepts here. Now from my vertex, out 4, up 5. 16 here. 1, 2, 3, 4, out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I know that point is going to be symmetric over here. And here is our parabola, which is exactly the same picture that we had over here. So factored form or standard form, a very long video, I apologize, to show you that they are the same. They're the same function, they're the same picture, standard form or factored form, because you could just multiply this and get this function over here. So your graphs should be identical.